Okay, so this video is for quiz 2. For those of you that had some problems you weren't sure how to work through, I just want to make a quiz video for the quiz part. So it's just good practice for this unit, lots of different types of problems so that you can feel like you can master it. So I just made the other video for the study guide, and the formulas kind of still apply for this. So these are the formulas that are pretty essential to know, which is the area formulas for these 5 shapes. This is my trapezoid. And then the volume formulas, they have a B in it, but the B represents a formula, an area formula. So the B, a capital B is different than a lowercase b. A capital B is an area of the base. So that's why I changed it to an A. So these B's are all different than these B's. These are in an area formula, so you're going to select one of these formulas to plug in for a B, versus these B's are just lengths on the picture. All right, then you'll also need to know Pythagorean theorem, density, and population density. Okay, so the first question on here, the diameter of a standard basketball is, diameter is 9.5 inches. And the basketballs are covered. So covered means around the outside. That's talking about area or surface, the surface of it. So what is the minimum amount of rubber needed to manufacture a set of 4 basketballs? So we need to figure out what the area on the surface is, the surface area. And if I give you a surface area problem, I will give you the formula for it. So the surface area for a ball, or for a sphere, is 4 pi r squared. That's the formula. That does not include the 4 basketballs. So you would just do 4 pi. The radius would be the half of the diameter, so 4.75 squared. So you get like about 83.5 for the surface area of 1 ball, and you have to times it by 4 because there are 4 balls. So it should have been 1134. Okay, on number 2, they give you the solids below are similar. You have the scale factor, surface area ratio. Okay, so you would look to see what they give you already. So this is in centimeters, so this is our hint that these things are scale factors. If they had been centimeters squared, it would be surface areas, and if it was cubed, it was volumes. So first we want to figure out what this simplifies to. That's always what we're going to do, simplify it. So 20 over 5 simplifies to 4 over 1, so that would be our scale factor ratio. That's A and B. Surface area is A squared and B squared. We're memorizing those on our formula sheet, or flashcard, so it's 16 to 1. And volume is cubed, so you take this and you cube it. So 4 times 4 times 4 is 64, and 1 times everything is 1. 1 times 1 times however many ones is still 1. Okay, so a pyramid, 2 pyramids are similar. The volume of pyramid A, so I'm just going to draw it. It doesn't tell us what kind of pyramid base it is. I'm just going to assume square, but it doesn't really matter. But it's just good to have a visual for me, I think. So you have pyramid A, pyramid B. The volume of pyramid A is 448 inches cubed and 189 inches cubed for pyramid B. Okay. If the height of B is 39 inches, they want us to find the height of A. All right, so normally we can just set up a proportion and solve. But because these are volumes and these are in just inches, we're not comparing like things. So we need to figure out what the ratio of the scale factors is, and then we can compare them we can write them in a proportion. So scale factor, surface area, volume, and we're given the volume. So 448 and 189 are the volume ratio. So let's see what that simplifies to. Alright, gives us a decimal. It's pretty standard, that's fine. So then you hit second arrow to get it to a mixed number, second ABC to get it to an improper fraction. So 64 to 27 would be your volume ratio. Okay, because height is in inches, we care about the scale factor ratio because that's the one we need to compare H to 39. So we use second 0 to get the cube root of these numbers, and then convert it to a fraction. Or you can cube root these separately. That'll give you 4 and 3. That's fine. Okay, so the ratio of the actual heights is 4 to 3. So that means they're in a ratio of 4 to 3, and it's height and 39. Okay, because the 448 was first, I wrote it first. I put the h first on this side. So it does matter that the h is over the 39. Okay, and we had to use the scale factor ratio because these are in inches, which inches is related to scale factor. So 4 times 39 is 156, divided by 3 is 52. So the second height should be 52 inches. Okay, the surface area of a figure is 24 square yards. They don't even tell us what kind of figure it is. So surface area is 24 square yards. If the dimensions are all multiplied by 7. So surface area means, let's just say the surface is, it even could be two-dimensional, it's just one surface. It's 24 yards. So these, this is 24 yards squared. If the dimensions, which are the sides of each of the sides, was multiplied by 7, that means the scale factor was A, which is 7. So we don't have really a B for this problem. Normally we have A and B. If you were dying to write a B, you would write 7 to 1. Okay, so 7 to 1 or 1 to 7. So if that makes more sense, so you can write it as 1 to 7. If everything was multiplied by 7, it was originally what it was, and it's times 7, so it's a scale factor of 7. What will be the surface area effect, or the new surface area? So the surface area effect would be A squared, which is 7 squared, so 49. So 1 to 49. So that means that the surface area, even though the sides all got 7 times bigger, the surface area actually got 49 times bigger. So you would take 24 and you'd multiply it by 49. I don't know why I wrote it to you. So it would be 1176 for the new surface area. So if you multiply dimensions by 7, so let's say, even if we had come up, let's actually just generically come up with 1. So we can put in some test values here. So in order to get us an area of 24, we could have a 6 by 4 figure. If these sides get multiplied by 7, this would be 28 and 42, which would make our area when we multiply for the rectangle now. $11.76. So that's why we got that. So if they give you an area, you can plug in some random numbers that make 24 to give you the sides, and then just calculate it. Or you can just see, okay, that means that the thing should be 49 times bigger than it was. Okay. So again, I put them in pencil because it doesn't give us those. We just know that that's what's happening. All right, number 5, how many times larger is the volume of a sphere if the radius is multiplied by 5? So the volume of a sphere is 4/3 pi r cubed, and the radius is multiplied by 5. In the formula, radius is cubed, so we would cube this effect. So 5 cubed is going to give us 100. So that means the volume is 125 times bigger, because 5 would get multiplied by this formula 3 different times for the cube. Okay, a group of friends is playing basketball. Sorry, it's playing baseball with some aluminum balls. Each of the diameter given. Okay. So we got some aluminum balls, 7.26 is the diameter. If the aluminum balls have a density is 22.7 grams per cubic centimeters, what is the mass of each ball? So the mass we're looking for is x, we don't know. The volume, we can figure out the volume of a ball because we know the volume of a sphere. Okay, if the diameter is 7.26, the radius is half of that. Okay, so cubed times pi times 4 divided by 3. So the volume would be about 200 2.36. And we're going to times that. To get x by itself, we would multiply. So the equation is 2.7 equals x over 200.36. Multiplying both sides by 200, x is about, by 2 points, 541. So if they're giving you density and you're looking for mass, you just work backwards. So really mass means, if mass is divided by volume, to get mass by itself, you'd multiply by volume. So d times volume equals mass, which is why we multiply these. The leaders of an after-school program are creating a rectangular garden against the back of their building with a fence around it so that instructors can teach. They only have 120 feet of fencing available for the project. What would the dimensions of the garden be if the builders attached one side of the fence to the building in order to make the area of the garden as large as possible? All right, so visualizing what's happening with the picture drawing is pretty helpful. So some leaders want to create a rectangular garden against the back of their building. So we have their building. We've got a rectangular garden with a fence around it so that the instructors can teach the gardening principles. Because they're going against the back of their building, their fence only needs to be around 3 of the sides instead of all 4 like it normally would. They have 120 feet of fencing available for the project. What would be the dimensions of the garden? What would the dimensions of the garden be if the builders attached one side of the fence to the building in order to make the area as large as possible? So they're not going to put fence against the building. So that means that if you have case A, we're going to try each of these. First of all, there's 2 numbers. So a lot of people ask, like, how do you know which dimension is which? Well, if you're trying to use only 120 feet of fencing, then you want the ones that's going to go double to be the smaller of the numbers. Because if you double the 60, that's going to be take up more fencing. So we would actually put the 30s here, 60 here. So that only uses, if I calculate the fencing that it uses 30 plus 60, so 90 plus 30, so this is used 120 feet of fencing, and the area is 1,800 square feet. Area is length times width. Okay. So the first case meets the requirement for the fencing, gives us a pretty big area of 1,800 feet. Case 2. No ambiguity about where to put the 40s because they're all 40s. So these are all 40s. So again, 120 feet of fencing. 40 times 40 is 1,600. Only 1,600 square feet of area. So it's a little bit less area for their garden. This one we would put the 25s as the smaller number, so we want to maximize fencing and double up on the 25s. So 25, 50, and 25 means we're only going to use 100. We're not even using all the fencing. They could have made that longer than they did. And then 25 times 50 is 125, 0. So it's not quite as much fencing as A or B. So it's actually the worst option so far. It didn't use all the fencing, and it gives us the least amount of area. And then D, we're going to double up on the 30s. So 30, 70 is 100, and 130. So it actually uses too much fencing. We only have 120, so we can't use D at all. Even if it gives us a lot of area, we don't have enough fence for that. So the choice that gives us the most area and that meets the requirement would be A. Okay, the local recreation center is building a new Olympic-sized pool, and they don't tell us what shape the pool is, but they do give us a hint about it because it says it's 6 feet long, wide, and deep. Since there's no radius or it doesn't tell us like, oh, this has got base 1, base 2, we can assume that it's a rectangular prism. So that's the rectangular prism volume is the best volume because that one is length times width times height is the quickest way to do it. It actually still follows the volume formula that we use for any kind of prism, but because the base is length times width, then the volume formula is length times width times the height. So that's why it's pretty nice. So just multiplying these 3 together. Okay, so it gives you 161,376 feet cubed. That's how much water the pool holds. Goes all the way to the top. So they need to dig the pool out, whoever's building this pool. So the excavated dirt means like the amount that they have to dig out of the ground in order to make room for the pool. Will haul away by wheelbarrow only 9 cubic feet of dirt at a time, which is ridiculous. So if each wheelbarrow only holds 9 feet of dirt, they want to know how many wheelbarrows will it take to get rid of all of this volume. So we just need to divide. Alright, so it's going to take you 17,931 wheelbarrows to get that job done. So you need to go ahead and buy a bigger wheelbarrow. That's what that means. It's too much work otherwise. Okay, so that's it. Okay, so number 9, we are close to the end. Janitors at Strickland High School empty 25 full trash cans every day. The design is shown here. Based on the information in the diagram above, what is the total volume of trash the janitors empty every day? So, we need to figure out the volume of this and then times it by 25 full trash cans. So this is made up of 2 shapes, and then though we don't put trash in this part, it's still even though we don't put trash in this part, it's still counted for this particular problem. So we have a volume of a rectangular prism and the volume of a cylinder, but it's only half of a cylinder because the bottom half of the cylinder isn't there. Okay, so we're going to do the volume of both and then add them together and multiply it by 25 bags. So we know length times width times height for the volume of the rectangular prism, and then the cylinder is pi r squared times height divided by 2. So now we just need to be pretty good at figuring out what dimensions are which. So the length, width, and height are pretty straightforward. Doesn't matter which one goes where, but you need to use all 3. Okay, the radius of the cylinder. So the cylinder it's a half a cylinder. So the radius of the cylinder would be this dimension, and this was 2, so this is going to be 1 foot. The height of the cylinder means the distance between circular faces, so this is actually 3. Okay, so it's 2 times 3 times 4.5 plus pi times 1 squared times 3 divided by 2. Okay, so these two together equals 31.7 in feet cubed. It was feet. This one dot means feet, 2 of them is inches. Okay, and then timesing it by 25 gives you 792.8 cubic feet of trash a day. Okay, if you rounded this number beforehand, then I gave you credit. If you put 0.5, it's fine. Okay, and lastly, we did population density. So population density is people over area, and we went around to the nearest square mile. Okay, so it's just going to be this number divided by this number, and you're seeing which one's the biggest. So 18,801, 310 divided by 53927. So this first one's 340, can't have an extra person, 348. It didn't quite reach 349 people per unit, so you can route it to either one. It's not going to make a big difference because all these are pretty close. I mean, they're not close. 196 or 5. $167. So even though Texas has the most population, because it has so much space, they have the least population density. So they're the least packed in there. Florida was the winner. That was the greatest population density. Okay, so good luck on your test tomorrow. I think you guys will do well.